Welcome back, everyone. So I hope you had time to relax a little bit. Welcome back. We will now move on to the use cases presentation, and our first speaker is Bojana Horvat from the University of Rijeka. So welcome, Bojana, and whenever you want, the floor is yours.
Yeah, hello, thank you for the introduction. With this presentation, I will try to present the work we did within the project that was concerned with flood risk assessment. I was, in fact, responsible for preparing the spatial data for the flood risk assessment. As you know, as required by the flood directive, each member state is obliged to create and design flood risk management plan, and essential part of those management plans are flood risk and flood hazard maps. Those maps result from the flood risk and flood hazard assessment. So in general, these are some general stages of flood risk assessment, which means first is derivation of probability and intensity of flood events and preparation of flood hazard maps, which is based basically on hydrological and hydraulic modeling. Then detecting the elements that are prone or exposed to flooding, and then relating those elements to monetary values and defining the flood damage that occurred during the flood. And in the end, of course, preparation of the flood risk maps. Each of these stages require a certain level of spatial and thematic detail in the data. However, not all the data is already available to be already applied at the various scales. Assessment of flood risk and flood exposure can be proceeded at 3 different levels. The first one is the largest one, which is macro level, and it involves pretty much coarse spatial data that covers the resolution of 100 to 1000 meters, then followed by the mesoscale, which is concerned with the smaller spatial units. Mesoscale can be applied to the catchment levels, and we were at this project concerned with this level. So it involves the spatial resolution of some 25 to 100 meters roughly. And the smallest and the most detailed level is micro level, which is actually the object level that covers the resolution of 1 to 25 meters. Although even on that level, a certain degree of aggregation needs to be applied, thematic generalization. We will not be looking at the separate objects, but we will need to group similar object into one class that we finally observed when analyzing flood exposure. As I said, at this stage, we did analysis at the meso catchment level, which means that we required spatially and thematically data that is more detailed than the data that was already available, but collecting new data requires more expenses and it's quite time consuming. So we had to deal with thematically aggregated land cover and land use data and spatially aggregated census data that we collected from the statistical institution. Anyway, when preparing the data, the challenge was to reduce this generalization in data that is more suitable for the macro level. And to introduce a certain level of detail that will make this data applicable to our mesoscale flood risk analysis. We considered, when it comes to land use and land cover data, we considered 4 Copernicus land use land cover data sets, which is Corinne land cover, Natura 2000, coastal zones, and urban atlas. Most commonly, Corina land cover was used in such cases, although this data set covers practically the whole continent. When it comes to spatial and thematical resolution, it is not well suited for the mesoscale, meso level analysis. So we had to consider other datasets, which is Natura 2000 and coastal zones. Of course, Urban Atlas is the most detailed when it comes to urban areas. However, it is available only for the certain regions. It's not available for the whole country, of course. So we had to apply certain regions, coastal zones, and Natura 2000. When it comes to thematical level, the most detailed in the urban regions is again Urban Atlas, followed by the coastal zones and Natura 2000, for example. It depends actually on the purpose of the actual data set. So if we were at this point, we were analyzing the data that refers only to the urban areas. So Natura 2000 is not thematically detailed enough. For example, it recognizes only one urban class, while coastal zones recognizes, I think, three urban classes. Urban Atlas, as opposed to those two data sets, recognizes four. So we adopted that classification when it comes to exposure analysis of the assets in the urban areas. Along with land use and land cover data, we also used impervious density data that is available also from Copernicus in raster format. It's 10 meters resolution, spatial resolution. And along with IMD data, we also use the impervious built-up areas that are derived from IMD data. And this IBU data refers to the surfaces that signified the above ground buildings. So not all IMD surfaces are considered to be above ground buildings. So we needed to restrict the data only to the areas that are covered with the residential or above ground buildings. When it comes to analyzing population that is exposed to flooding, we had to use census data. But also the census data has a certain degree of generalization since it is collected at the settlement level. By that I mean the administrative boundaries of the settlements, which is illustrated in this choropleth map of the census data, population density data for the settlements in our research area, which is the Zadar catchment. So we had to apply certain disaggregation not only to land use land cover data, but also to the census data, so we can proceed with exposure analysis at the meso level. Data disaggregation is nothing more than regionalization of the observed data using some auxiliary data. In our case, we used imperviousness density data as auxiliary and applied it to both census and land use land cover data. After finishing the exposure analysis, we did the flood damage analysis, which means connecting these exposure results that we got with some monetary values via depth damage curves that are already available for the whole continent, for the EU countries. Just to proceed with data disaggregation, we needed to make certain assumptions. Since we used IMD data and IBU data as auxiliary data, so we assumed that population density is directly related to the impervious density, which means the higher the IMD values, the higher the population density will be, and more population will be exposed to flooding. Then we assumed that population resides only in the built-up areas that we got from this IBU layer, derived from IMD layer. And that we also assumed that IMD indicate the density of the built-up areas, not only the population density areas. By intersecting those auxiliary data with urban fabric that we extracted from the available land use land cover data, we got IMD spatially restricted to those residential areas, and then we overlaid it with census data to get the surfaces within the settlements that are probably occupied by the population. That's roughly the methodology we applied. When it comes to disaggregating thematically the land use, land cover, urban fabrics, it was more or less easy because we applied the same thresholds that were applied to Urban Atlas, which means we classified IMD data into 5 classes based on those thresholds adopted from the Urban Atlas. In this table, I just put also the thresholds used in other land use, land cover classes, just to illustrate the discrepancies between level of detail in all those used land use, land cover data sets. However, when it comes to population density, the process was a bit more complex because we had to restrict the census data that we collected from the statistical institution to only those IMD polygons that are considered to be populated by people. This is the illustration of how we disaggregated population density data. We applied asymmetric population mapping, which is often used in these cases. First, we needed to establish the initial number of inhabitants in the areas that we previously extracted as the areas that is probably populated. And to do so, we had to use IMD as the weighting coefficients to assume the density at the certain levels of IMD classes. Then we, with the procedure that is described here, we limited the initial number of inhabitants to those areas that were distinguished in the previous steps, and estimated population density first on the pixel level, and then aggregated it to the polygon level of the land use, land cover data set that we adopted for the certain region. To validate results, we used the case of Zadar catchment because we had Urban Atlas data available for this catchment. So when we compared calculated, estimated, and actual number of inhabitants and population density, we actually got pretty good results. Just to conclude this short presentation, we established that this disaggregation technique that we based on functional relationship between the aggregated and auxiliary data, in this case IMD, is one way of dealing with lacking the data that has no sufficient thematical and spatial detail. We used already available Copernicus land cover, land use, and IMD data. So we used it as the auxiliary data to disaggregate not only the exposure of the assets, but also the exposure of people in the flood-prone areas. However, we have to emphasize that this approach is limited by the existence of the census data. If the census data is collected at the settlement level, this approach can be applied. However, it is not always the case. In this case, some other data sources needs to be used for the census data. For example, I put here illustration of the world pop data, which is available at 100 kilometers resolution. And also one drawback in this specific study was that we used census data that registered only the residents that are living at the actual settlements. We didn't take into consideration daily or seasonal migrations due to work or due to tourist season. So in some further steps, this also needs to be taken into consideration. Okay, so that would be it from me. I see that I'm practically in time. So if you have any questions or suggestions, I'm very open to it. Thank you.
Thanks a lot, Bojana, for your nice presentation. So at the moment, we don't have any question. We can wait a few seconds if some are coming. Okay, so yeah, we have question. Up, so I will wait till it appears on the screen. Okay, so this question, so the data is used from a static source or processed real time. Thank you.
No, the data is used from the static source. It's not real-time data. We use the census data that was collected, I think, in 2021. And land use land cover that was derived from Copernicus land monitoring service.
Thanks a lot. So this question, so this one is a general question. Where can we access the presentations that have been done so far? So all of the PDF presentation will be made available on the website just after the event. You will see an option with replays and presentation. So you will be able to access the presentation and take a look at the slides. This question, how to aggregate data from extreme flood events?
That's a difficult question to answer. Yeah, I have no experience with aggregating from these extreme flood events. Yeah, well, aggregation is actually, in my opinion, would be much easier than disaggregation of the data if you have some the spatial units to which you have to aggregate the data that you got from your studies. I think it's quite straightforward in GIS environment. Yeah.
Okay, thanks a lot. So we have this question saying the world pop is it not 100 meter or is it 10 kilometers spatial resolution? I'm not sure to understand the question.
Yeah, well, I'm could be that I wrote the wrong resolution. I'm not sure actually now. I think it's 100 meters. Yeah.
Okay.
Yeah.
Okay. Thanks for the precision. So we have this question: if the disaggregation method can be used for different studies, like the human pressure hunting on a species.
On a species.
Species.
Well, I'm not sure if that would be possible. Actually, this method specifically is designed only for detecting the elements exposed to flooding, static elements exposed to flooding. So I don't know. Maybe if you find a way to apply this method, I would be very happy to hear about it. Yeah.
Yeah. Maybe there is work already done on this. We should look on the internet. Okay.